Hello, Mr. Mr. Ryan, am I right? Yeah. Okay, so let's say we have numbers, yeah? 1, 2, 3, 4, 5. Yeah? Okay. 6, 7, 8, 9. Go. Yeah, these 9 numbers, yeah? If you want to pick k numbers, these cannot be duplicated. So, for example, like if I pick k equals 3 numbers, and n is the sum, n equals 7. So basically, picking 3 numbers, you can only use one number once. Yeah, you can use any digit, any number once. Let's pick 3 numbers out of these 10 numbers, and each number can only use once. And then, can we get a list of the sum to 7? Do I make myself clear? So basically, we need to pick 3 numbers.
1, 2, 4.
Well done. 1, 2, 4. So can you tell me if k is bigger than 9, do we have a solution?
Because there are only 9 numbers.
And then if we pick more than 9 numbers, what will happen?
There will be no numbers to use.
That's right. There will be duplicated. You can't reuse the number. Okay. So k equals 9. We need to return an empty list. And how about the sum? Can we put a constraint on the sum? Each number we need to pick at most once. So what's the biggest sum that the list can have? So what's the biggest?
24.
Why is it 24?
7 and 8 and 9.
Not talking about this. Yeah, you are very right. I'm talking about any k and any n. So what's the biggest n that a list can have, given the constraint that we are using only each number once? You are very close. If we're picking 3 numbers, 7, 8, 9. How about if we're picking
45.
Where down? How do you connect to 45?
Because all other numbers equal to 45.
Which numbers? How do you get this 45?
1 plus 2 plus 3.
Exactly, yeah, because this k, 9 number, is it 9 numbers? 1 plus here 9, okay? Yeah, if k equal bigger than 9 or n bigger than 45, then we need to return empty list because there's no need to search, right? Because it's not satisfying the fact that we only picking one number once. Pick one, at most once, yeah? At most once each number. So what's your thought? What's your thought? How can we do this? We can use the preferred search. We can use the preferred search. That's also okay. And default search. Default search, in this case, we can do some branching. So that will be a backtracking. So for example, let's say let's start from picking first number, yeah? Okay, let's say picking first number 1. At the beginning, we have empty. Picking first number 1, yeah? Do we have enough k numbers? Yeah, if we have enough k numbers, we check the sum if it's equals to n. Right? If it is, then we put this into the list. If not, we continue. The next number we can pick is more than 1, right? Because we cannot reduce. Can we pick number 2? Right? So we try to pick each number, and then we'll try to see if we have enough k numbers. Also, if we have already the sum, right? Then if it satisfies the both requirement, then we put the candidate list into the array, right? Yeah. And in the cases, if we have more than k numbers, we return. We just go back. For example, like if we only have k equals 3, yeah, 1, 2, 3. Then if it's more than 3 numbers, so we just go back. We don't continue pick, right? And if it's the sum, look. If its sum is bigger than the current sum, is bigger than the sum, then we don't need to continue, right? Because currently what we have is more than n, so there's no need to keep picking. Am I right? Yeah. Okay, so this kind of thing is default search, and if we apply the branching, that will actually become a backtracking. What's backtracking? Backtracking.
Looking back.
So basically, look, you visited the tree, right? You visit the tree, and then you find out there's no need to continue. You go back tracking, right? You continue to dig as further as you can, but at some point you realize there's no point to keep picking the next number. Why is that? Because there could be 2 things. One is we have picked more than k numbers, or currently the numbers on our basket, the sum is more than n, right? So if one of these satisfied, there's no need to continue. Then we go back, right? So we don't waste the time keep picking other numbers. Yeah, it's like picking number, you have a basket, you have numbers, you try to pick each numbers. Yeah. Now you have a big basket, and then if we want to pick, look, k equals 3 numbers, n equals 7, the sum. Right? This is the basket. This is the available numbers. Yeah? Available numbers. Okay, currently my basket have 1, 4, 8. Do I need to continue picking the numbers, taking the numbers, put it here?
No,
Why is that?
because it's you're gonna get over k numbers.
Yeah. And also, okay, so that's maybe here. Do we need to pick any other number?
No, because it's over n.
Yeah, exactly. Okay, and how about look at 1 and 2 and 3? Do we need to pick another numbers?
No.
Because one more number will become more than 3 numbers, right? Exactly, right? Let's kind of backtracking. So,
like 1 and 23.
yeah. So basically, this is like the thing, yeah. We, at some point, it's a depth search, it's in a depth search, but we apply some logics in it, yeah. If we don't apply this logic, we keep finding the numbers. Look, then we pick all the combination, right? And then there's no point because they're not part of the answer. We don't waste the time doing that. It's like a tree, yeah. We don't waste the time doing that. There could be a massive tree here, but we don't explore it. Why is that? Because we found out there's no point keep doing that. We already know, no matter what numbers chosen from now, yeah, it won't be part of our collection. Okay, so let's implement this depth search, and then that'll be it. First of all, we have this answer. Yeah, answer. Then we have to check if n is bigger than 45 or k is bigger than 9. Then we return empty list. Yeah, there's no point to continue. Okay, bear this in mind. Okay, this is very important. Optimization. And then we have this depth search. Okay, so we have the current selection, and we have the next number to pick. Let's say 8. Okay, right? And then I want to do this depth search. At the beginning, we started an empty basket, and we start from the first number, right? Let's say we start from the first number. Okay, so now if the length of current is bigger than k numbers or what? Or the sum of the current is bigger than n, then there is no point we return. Okay, and then we do another check. If length current is equal k and the sum current is equal n, then we put this current to the answer. Yeah, answer dot append current. Okay, we need to make a copy of the selection because it's a list. We need to make a copy, dig copy. Okay, look, this is the dig copy. This one, yeah. So this is an array, yeah, array. 1, 2, 3. If I say b equals ARR, this is an alias array. It's not a copy. Then we need to do this. Okay, put this column. That's a dig copy, and then we return. Otherwise, we try the next number. For I in range, we start from the next number, right? Next number would be A plus 1 to 10 to 9 actually included. Then depth search current plus I. Actually this is A. We start with the A to the next number. If we pick the current number I, then the next number we can pick is greater because we can't pick the I again, so it will be I plus 1. Okay, yeah? And then we just return answer. Okay. Yeah, that's the backtracking, depth search, backtracking, okay? Okay, so the thing is that look, every time we need to do this sum, we can accumulate a sum when we do this depth search, right? Look, currently, every time every iteration, every recursion call, we need to do this, and this is very time consuming. And we can do some optimization is by putting this sum. At the beginning, we haven't picked anything, so let's put the sum 0 here. Okay, and then I change here to current sum. Instead of sum current, and we can do this current sum. Yeah, and this is the same current sum. And then we pick the number I, so the current sum needs to be updated. Current sum plus I. Okay. Yeah. So the time complexity is quite tricky without this. With this. Yeah, because look, with this, n is bigger than 45 or k is bigger than 9. Then we just return empty list. There's no point to search. So with that in mind, the problem is actually bounded by the constant. So the time complexity will be 01. Do you get me? Yeah? Do you get me? Because we have this problem, the upper bound is bounded by a constant. Yeah? Because when the size is bigger, then there will be, we don't continue, right? So there's limited. But if we don't consider this bit, this is the thing as that there's nine numbers, we picking k numbers. Yeah? What we talk about the C 9 numbers, picking k numbers. Yeah? Equals what? C is the combination. Picking 4 apples, picking 2 apples. How many ways? There are 4 apples. Picking 2 apples. It's hard.
Let me think. 1, 2, 3.
No. 4 apples.
5, 6.
Okay, let's see. This is equals to 4 factorial divided by 2 factorial divided by 4 minus 2 factorial. Equals what? Equals 4 times 3 divided by 2 times 1 is 6. Yes, you're right, 6. C, combination. Yeah? The permutation is with orders. Yeah? So permutation is actually without, P42 is actually without these 2 terms. Yes? 4 factorial divided by 4 minus 2 factorial. Okay? Let's write it. P and M. N items, picking M items with orders. Yes, so n factorial divided by n factorial divided by n minus n factorial. No, without this. Okay, so this is the permutation. Yeah, permutation. 1, 2, 3. 3 number, 4 permutation. 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. There's 6. Yeah, 3 factorial equals 6. Yeah. First of all, we perform the permutation and then we divide it by m. Okay, look, this is n for permutation, right? So then there'll be a combination, right? Yeah, because all these 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. This is one combination, right? One combination. So we divide it by 3 factorial. This is what it is here, n factorial here. Okay? Think about this way, okay? So the time complexity without looking at this one is C9K, okay? And then at the end we need to make a copy of the combination, so it's times K. Right? Yeah? It's a iterator. From iterator import combination, yeah? Actually this is already provided, and we have also permutation as well. So what does this mean? Combination. So we can do this combination, and then we can have this range. The first one parameter is the iterator. We want to perform the combination of the 1 to 9 numbers, and we want to pick k numbers. Yeah. So this gives the combination, and then we just have to check if any combination of these. So return x for x in list 1, yeah? And this is the iterator, so we have to convert it to a list. If sum x equal n, simple as that. Look, combination. The same thing goes with permutation. Combination. The first parameter is the thing you want to pick, the apples, right? So we want to pick k numbers out of 10 numbers, and we want to check if any of them sum up to n. Wow, look, simple. Yeah, simple. Got it?
Yeah.
Yeah. For example, like combination. Yeah, combination. Let's say 1, 2, 3. And then if we want to pick 2, if we want to pick 2, so what does it give us? It will give us 1, 2, 1, 3, 2, 3, and that's it. Look, very powerful. And then for the permutation, if we change this to permutation, what does it give us? It will give us 1, 2, 1, 3, 2, 3, and then the reverse, yeah? 2, 1, 3, 1, 3, 2. Okay? Yeah? Look, permutation. Different order is kind of counted as a different permutation, but combination is the same. Okay? Yeah? Okay, what have you learned today so far? Today, that's
We
it.
learned about combination sum.
Okay, so what's the problem? What's the problem? Do you still remember? What's the problem?
So you have n numbers, obviously.
We have 10 numbers, 1 to 9, and then we can pick 10 numbers, so it sums up to n, right? So we can do this backtracking. Yeah? Backtracking is basically the depth search with some branch optimization. Right? So we cut off some branch when we realize there's no point to continue. Right? This is the backtracking. Okay. And then we also can use the breadth search, but yeah, given time, we're not implementing it today. And then we also talk about this iterator. From iterator, import combination permutation. We can use this one. Return x for x in this combination, range 110. This is the 10 numbers. We want to pick k numbers, do the combination. I want to check each combination. Which combination sum up to n? Okay? That's it for today. Bye bye.
Bye.